Okay, let's go over the basics of graphing some quadratic functions, just in a real basic form, how to graph these functions. So the first one I've got is y equals x squared. So what that means is any value of x, I'm going to take it and multiply it by itself to get my y value. So for this, if I had, let's say x is 0, if I had x is equal to 0, 0 squared would still just be 0. Then I could go up this way, 1, 2, 3. 1 squared would be 1. 2 squared would be 4, and 3 squared would be 9. Going down the other way, if I do negative 1, remember anytime I do a negative times a negative, and the same if we're putting it in the calculator, if I wrote in the calculator negative 1 squared, it's going to view it as negative, and then the 1 and squared it's going to put together, because this negative it shows as multiplying by the 1, and you do exponents before you multiply. So if you put it in the calculator, just remember to put that parentheses, even though we should know negative 1 squared. It's going to give you a positive 1 there. So that'll run the same for negative 2, gives me a positive 4, and a negative 3 gives me a positive 9. And so what we have here is a parabola. It starts at 0, 0 as the vertex, and goes to 1, 1, 2, 4, and 3, 9. Then negative 1, positive 1, negative 2, negative 2, positive 4, and negative 3, 9. So we get our nice parabolic shape there. And so this would be the parent function for all of your parabolas, all of your quadratic functions. Everything that we look at from here on out is just going to take this graph, and starting out, we'll just kind of move it up or down, left or right, and then also we can widen it or make it skinnier. So the first form we have with this is translation form. It says y equals a times x minus h squared plus k. So if you notice, this looks a lot like our point slope form for linear equations. The k, we could just think of it as being moved over here with the y, and it would be y minus k equals a times x minus h squared, which would be just that point slope form. This is just moved over in a way that you're able to put it in the calculator. So I want you to notice that if we take the opposite of whatever h is, and just whatever k is, that'll give us our vertex as the x value and the y value. And so you don't necessarily have to know that that's how this works out, but the benefit of it is, if I know where the vertex is, it makes finding my points a whole lot easier. So I'll take the opposite of negative 5, that's my x value, and take my y value over here just as it is, a negative 8. So I know my vertex should be a 5, negative 8. And so then I'll put in a couple more numbers, so 4 and 3. And we'll get some information off of that. And we'll put a 6 and a 7 there. So if I put a 4 in for this, 4 minus 5 would be a negative 1, which gives me a positive 1. So what's happening here is I'm just putting those in, and we'll work it out here. 2 times, and instead of x, I'm going to put a 4. 4 minus 5 squared minus 8. So that gives me a negative 1, but that squared gives me positive 1 times 2 minus 8 should give me a negative 6. Okay, for this one, if I put a 3 in there, it'd be 2. It's 3 minus 5 squared minus 8. That would give me And negative 2 squared gives me 4, times 2 gives me 8, so 8 minus 8 would give me 0. Okay, so if you're to work out these other two, what you'll quickly notice is that when I put in a 6, I also get a negative 6, and when I put in a 7, I also get a 0. So let's look at a couple of the important things we have for this graph. The first is the vertex, which we've got. The next will be our roots. So on this one, we've got roots of, and we're going to want it when it crosses the x-axis, so our zeros here. My roots would be 3, 0, and 7, 0. And then my axis of symmetry is just the x value of wherever my vertex is. So we'll say it's x equals 5. So let's graph it out and we'll kind of see those in action. So I'll start with my vertex and go over 5 and down to negative 8. Oh, went too far on that one. There we go. So I end up with skinnier parabola going up like that. But if you'll see, right where the vertex is, I can cut that in half, and I've got an axis of symmetry there. So I know basically what that means is, if I find a couple points over here, I can mirror them to the other side and get the other side just like that. Works the same on our first one here. So my axis of symmetry here would be x equals 0, because that's right where the vertex is. And also, my root would be a 0, 0, and that's actually a double root, which just means it only hits it once. So there should always be 2 roots, but since this hits it once, it means if we work this out, then the root that we saw for 0 would be just 0, 0 for both. Okay, for the next one, let's find the vertex, and that'll give us the axis of symmetry, and we'll use that to graph the rest of the function. So I've got y equals negative 1, x plus 5 squared. So I know I need the opposite of this. My vertex would be negative 5. And then my y value is whatever k is, so there's nothing there. So in this instance, that means that's a 0. So let's start with my vertex, negative 5, 0. And see what we get from here. So if I put in a negative 4 here, it would be negative 1, negative 4 plus 5 squared. That would give me a 1 there. So 1 squared would be 1 times negative 1 gives me just a negative 1. When I do the same thing with the negative 3, negative 3 plus 5 gives me a positive 2. Squared gives me a positive 4. And that's made negative by the negative 1. So that'd be a negative 4. And then if I put a negative 2 there, I end up with a 3 squared, which is 9. So a negative 9 there. So I can graph those points. So I'll go to -5 and zeros right there. -4, -1, -3, -1, 2, 3, -4, and -2, -9. So we've got the 1/2 of it, and I'll just use symmetry to find those other points. And from there I can graph my parabola. So I've got a vertex of -5, 0. That would also be a double root because it only crosses the x-axis at one point. And it would be my axis of symmetry there at the -5 as well. So that gives you the translation form. Make another video here about doing the root form.